Hello everybody, getting ready to do lesson 5.5 classwork part 2 of pre-calculus math today. And part 2 of multiple angle product of sum formulas. You have 8 points here that will go into your notebook or your notebook guide. If you need a notebook guide, email me for that. And then 68 points here on your classwork sheet today. And then today's bell work, teachers and students, today's bell work, find radian measure of this situation, and then find the length of the arc of this situation. Looks a lot familiar to me, so you should be able to knock this out in 5 minutes. Okay, welcome back for our bell work today. And we have, for this situation, we need to find a radian measure. So when we do that, we have to take our radius, and we divide our radius into the length of an arc, which is the arc length is 7, our radius is 15 here, so it is the arc length is S, and then our radius is R, so S equals R theta. That's our formula that we use. And then when we crank this out, we get 0.467 radians for this situation of radian measure. And then down here, the length of the arc, S equals R theta. And then we got 21 centimeters here times 35 degrees. And then we use our conversion factor here to find the length of the arc. We got to go from pi 180 times this. Crank that through, and we get 12.8282 centimeters for the length of the arc with this situation here. Radius of 21 and a central angle of 35. Okay, into your notebook, students. Half angle formulas. You can derive some useful alternative forms of power reducing formulas by replacing u with u over 2. The results are called half angle formulas. And here they are. Sine u over 2 equals plus or minus radical 1 minus cosine u over 2. Cosine u over 2 equals plus or minus radical 1 plus cosine u over 2. And then tan u over 2 equals 1 minus cosine u over sine u, which becomes sine u. This becomes sine u over 1 plus cosine u. The sines of u over 2 and cosine u over 2 depend on, this is your plus or minus, on the quadrant in which u over 2 lies. So the key here is the quadrant in which your angle u is. So in this situation here, we have a plot here of a unit circle grid, or an axis here for a unit circle, using a half angle formula. Find the exact value of sine 105 degrees. So begin by noting that 105 is half of 110, so that's kind of handy. Then using our half angle formula for sine u over 2, and the fact that 105 lies in quadrant 2 over here somewhere, you have sine 1 over 5 is the same thing as radical 1 minus cosine 210 degrees over 2, which becomes 1 minus the negative cosine 30 degrees over 2. And then when you plug in exact values from these equivalent expressions up here, you end up with this expression here, radical 2 plus square root of 3 over 2, which when you simplify that, the positive square root is chosen because sine theta is positive in quadrant 2. Your sine over here is positive. Okay, so we go into our guided practice here. Use half angle formulas to determine the exact values of sine, cosine, and tangent of the angle. So sine 75 degrees would be the same thing as sine 150 over 2. So knowing that, we can plug it into our half angle formula here, 1 minus cosine 150 over 2. And then when we get our exact values from this, cosine of 150 over 275 is our cosine. So that would be in our quadrant 1, which is positive for cosine. So it would be positive square root of 3 over 2 over 2. And then when we simplify this down, we end up with the radical 2 plus radical 3 over 2 for 75 degrees. And then for sine 75 equals 150 over 2. Tan 150 over 2. Tan 75 is the same thing as tan 150 over 2. So I'll let you solve that. Okay, example 6, solving a trigonometric equation. Find all solutions of 1 plus cosine squared x equals 2 cosine squared x over 2 in the interval 0 to pi. So 1 plus cosine squared x equals 2 cosine squared x over 2. That's our original equation. And then when we put that into a half angle formula here, 1 plus cosine squared x equals 2 times plus or minus 1 plus cosine x over 2 squared. This is our half angle formula. It simplifies it way back. And then this will come into 1 plus cosine squared x equals 1 plus cosine x. This cancels. And then this becomes cosine x here. Then we have cosine squared x minus cosine x equals 0. We move our cosine x and our 1 over there. So now we have cosine x multiplied by cosine x minus 1. And then we solve for each one equal to 0. We use our 0 product property. So by setting factors cosine x minus 1 equal to 0, you find that solutions in the interval 0 to pi are x equals pi over 2, or x equals 3 pi over 2, or x equals 0. And this graph here confirms that right here. You can see where this corresponds to the zeros here for that. So you can conclude that the approximate solutions of this expression in an interval 0 to pi are these values here, which are again confirmed by the graph. Let's try one now. Find the solutions of the equation in the interval 0 to pi. Use a graphing calculator to verify your answers. So we have sine x over 2 plus cosine x equals 0. So when we put that up, sine x over 2 plus cosine x equals 0. So we need to solve for 0 for each of these. Sine x over 2 plus cosine 2x over 2. We plug that in there using our half angle formulas. Cosine 2x times x over 2 will be the same thing here when these cancel out. And then sine x over 2 plus 1 minus 2 sine squared x over 2 would equal 0. And then 2 sine squared x squared, 2 sine squared, so we have 2 sine squared x over 2 minus sine x over 2 minus 1. So let's see, 2 sine squared x over 2, that would be this here, minus sine x over 2 minus 1. We're going to put this out in front here, equals 0. And then solving each for 0, 2 sine x squared plus 1 multiplied by sine x over 2 minus 1 equals 0. Okay, so we factor this back into this. What's that going to give us? Well, that's going to give us, we're going to solve this expression for 0, and then we're going to solve this expression for 0. We separated them off. And then when we solve both these for 0, we're going to move our negative 1/2 over here. Sine x over 2 equals a negative 1 over 2. when we multiply this out. And then x over 2, when we move our sign over here, x over 2, sine x over 2 equals 7 pi over 6 and 11 pi over 6. And then x would equal 7 pi over 3 and then 11 pi over 6. So our half angles would be this, and then our full angles would be this here. And then over here, sine x over 2 equals 1. Move this over here. And then we solve for sine x over 2 equals 1. We have x over 2 equals pi over 2, because the sine 1 over sine would be pi over 2. And then x would equal pi when we multiply both sides by 2. X would equal pi. So only x equals pi is in the interval of 0 to pi. These are going to give us a true. This is an extraneous solution here. This is not in 0 to pi. This is extraneous solution here. And then so is that. So these are extraneous. Okay, moving on to our next slide here. Product to sum formulas. Each of the following product to sum formulas is easily verified using the sum and difference formulas discussed in the preceding section. So, product to sum formulas. Sine u sine v equals the 1/2 of cosine of u minus v minus cosine of u plus v. And then cosine u cosine v would equal 1/2 of cosine u minus v plus cosine u plus v. These have a sign difference. And then sine u cosine v equals 1/2 of sine u plus v plus sine u minus v. And then cosine u sine v would equal 1/2 of sine u plus v minus sine u minus v. So again, we have a little sign change here. When we put this out in front, we have a sign change because of that. Product to sum formulas are used in calculus to evaluate integrals involving the products of sine and cosines of angles. So in calculus, we'll definitely use those formulas. Writing products as sums, rewrite the product as a sum or difference. So cosine 5x sine 4x. Using the appropriate product to sum formula, you obtain cosine 5x sine 4x, and then we use our product to sum formula down here, and then we plug in our values here. 1/2 of sine 5x plus 4x minus sine 5x minus 4x. And then this, when we simplify this inside the bracket, we get 1/2 sine 9x minus 1/2 sine x. So let's try one here. Use the product to sum formulas to write the product as a sum or difference. So sine 5 theta cosine 3 theta. When we use our product to sum formulas here, we get 1/2 sine 5 theta plus 3 theta plus, because there were signs out in front, sine 5 theta minus 3 theta. And then when we simplify this inside of our bracket, we get sine 1/2 of sine 8 theta plus sine 2 theta. That would be the right product as a sum or difference. So here is our sum or difference. So we take this and we turn it into this here. And then you could graph these to check it. And then down here, the same thing here for 3 sine 2 alpha sine 3 alpha. We're going to have our 3, and then here's our 2 alpha, and then sine 3 alpha, be 1/2 of cosine 2 alpha minus 3 alpha minus cosine 2 alpha plus 3 alpha. We have a double sign here, so we have a different second. It's a completely different formula than up here, completely different. And then when we simplify what's inside the bracket here, we get, when we multiply this out, we get 3 over 2 cosine minus alpha minus cosine 5 alpha. Bracket would be further simplification here. would be cosine alpha minus cosine 5 alpha multiplied by 3 over 2. Okay, your notebook. Occasionally it is useful to reverse the procedure and write a sum of trigonometric functions as a product. So whatever works, and in some situations it's easier to reverse the procedure. This can be accomplished with the following sum to product formulas. Sum to product formulas: sine u plus sine v equals 2 sine of u plus v over 2, cosine u minus v over 2, and then sine u minus sine v. This is sine u plus, this is sine u minus. We get 2 sine u plus v over 2. This changes this into a 2 cosine out in front here instead of a 2 sine with this negative. And then this becomes sine here instead of cosine. Sine u minus v over 2. And then for the cosine u plus cosine v, like our sine up here, the difference is 2 cosine u plus v over 2, and then cosine u minus v over 2. And then cosine u minus cosine u minus cosine v, like here in this sine. This we put a negative out in front here. We go to negative 2 sine u plus v over 2 multiplied by sine u minus v over 2. So it's a completely different manifestation of from going from there to here. It's not really intuitive, that's for sure. Okay, into our next example here. Using the sum to product formula, find the exact value of cosine 195 plus cosine 105. So using the appropriate sum to product formula, you obtain cosine 195 plus cosine 105 equals 2 cosine 195 plus 105 over 2. So we're going from this into we're going from a sum to a product here. And then cosine 195 minus 105 over 2. And then when we simplify this out, we get 2 cosine 150. This reduces down to cosine 150, and then cosine 45 here. And when we plug in our exact values here, 2 times cosine 150 is negative square root of 3 over 2, multiplied by square root of 2 over 2, which becomes the negative square root of 6 over 2. Okay, let's try one. Use sum the product. So we have a sum here. We're going to go sum the product. And then same thing here. We have a difference to a product. So let's try them. Sum to product. So we use our sum to product here. 2 sine. We use our sum to product formulas here. 195, 105 over 2. Cosine 195 over 105. And then this becomes this down here. Then we use our exact values from this formulation here, and we end up with that. Then down here we have a difference, and then we go from our difference. Remember the negative 2 sign out in front. That works here. We have 120 plus 30 over 2, sine 120 minus 30 over 2. And then from those we get our exact values from this up here. Sine 75, here's our exact values for that. And then sine 45, there's our exact values. We further simplify here, negative 2, so we multiply these together, then we multiply by that. We end up with negative 1/2 radical 4 plus 2 times radical 3. Okay, into another example here, solving a trigonometric equation. Find all solutions of sine 5x plus sine 3x equals 0 in the interval of 0 to pi. So for that one, sine 5x plus sine 3x equals 0. That's your original up here. And then we can use our formulas here. 2 sine 5x plus 3x over 2 cosine 5x minus 3x equals 0. That's our sum to product formula. We have our sum here to product. Then 2 sine 4x cosine x equals 0. We simplify that by setting the factor sine 4x equal to 0. So sine 4x equal to 0. You can find that the solution's in the interval. Okay, so for these solutions in the interval 0 to pi, they are 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, and 7 pi over 4. The equation cosine x equals 0 yields no additional solutions. You can use a graphing calculator to confirm the solutions as shown. Here's all your solutions down here. For sine 5x plus sine 3x, notice that the general solution is where n is an integer and x would equal n pi over 4. In this situation here, you could assign a general solution for it, n pi over 4. Okay, let's try one here. Find the solutions of the equation sine 6x plus sine 2x equals 0 in the interval 0 to pi. Use a graphing calculator to verify your answers. So for this solution, we can go to a product here of 2 sine 6x plus 2x over 2 multiplied by cosine 6x minus 2x over 2 equals 0. And then this will reduce to sine 4x cosine 2x. When you like factor out here, excuse me, sine 4x and 2 sine times this will end up with cx, c2, 6x. When you multiply these two together, you will get this product here. And so when we divide this product up into sine 4x equals 0, we arrive at x equals n pi over 4. And then over here, cosine 2x equals 0. Solving for x, so we go 2x equals, the cosine of 0 will be pi over 2 plus n pi. And then we divide through, we'll get x equals pi over 4 plus n pi over 2 for this solution here. And so these are your array here of solutions. X will equal n pi over 4, and then another solution would be x equals n, or rather pi over 4 plus n pi over 2. And if you graph this expression, you will see these solutions. And that's 5.5 part 2, pre-calculus math. Email me here for course materials. Thank you very much.